In this video, we're going to look at complex numbers and how we can solve quadratics using complex numbers. Okay. So obviously, don't forget, it might be a while since you've seen this. A quadratic, we just talk about ax squared plus bx plus c equal to 0. And one really useful tool to have if you want to solve a quadratic, you should hopefully you should know a couple of techniques. So first of all, you can try and factorize the quadratic. You can also use the quadratic formula. And you could also complete the square. And in this video, we're going to look at all of those different techniques and what happens when we get quadratics that give us complex solutions. Really important that we remember while we're doing this, if we end up square rooting a negative, we know that the square root of -1 is just this thing that we're calling I, which stands for the imaginary component. One thing I probably should mention, right, a complex number, when we talk about complex numbers, they're going to be of the form a plus bi, so it would have a real part and an imaginary part. So this bit here, when we square root the negative, just gives us our imaginary part. It's not just going to be imaginary, it might be real and imaginary. So if you get, like, for example, if you had 3 plus 2i, or if you had -5 plus 4i, that is what we would call a complex number, real and imaginary. Okay? So let's look at this first one that's not on the sheet. If we wanted to solve x squared plus 9. Okay, you might think, can I factorize it? Nope. Quadratic formula, you can try the formula, but I'm not going to do it for this one because it's just an x squared and a 9. If we rearrange, we can say, well, x squared equals -9. And then you'd normally stop, wouldn't you? Because you go, well, there's no real solution. But obviously, now we've got a complex solution. So what we do here, if x squared equals -9, square root both sides because you want to get x on its own. When you square root both sides of this equation, please don't forget you need plus and minus. Quadratics give us two solutions. Look at the quadratic formula, plus or minus. You add a bit on, you take a bit off. You normally get two solutions from your quadratics, don't you? Exactly the same here. So when we square root both sides of this equation, we've got plus or minus the square root of -9. Now the square root of -9 we could write as the square root of 9 times by the square root of -1. So we get plus or minus the square root of 9, which is 3, square root of -I, which is, square root of -1. Don't forget -9 is just 9 times -1. And then when we square root -1, we get I. Okay. Okay, so example 1 in the booklet says solve x squared minus 6x plus 10 is equal to 0. We could use the I'm going to show you two ways to solve this, okay? It's nice to have two different techniques because then you can choose which one you prefer, and also it's good to have a recap on both topics because it's been a while since you've done quadratics. We could use the quadratic formula, okay? You may want to just make a quick note. A is equal to 1, b is equal to -6. C is equal to 10, so our solution would be minus b, so minus 6 would be 6, plus or minus the square root of b squared, so -6. Bracket's important because that's going to become negative, that's going to become positive when we square it. -4 times a, which is 1, times c, which is 10, all divided by 2a, which is 2 times 1. Okay, so let's simplify inside our square root and see what we get. Okay, so that's going to be -6 squared is 36, -40, so 36 minus 40 would be -4, all divided by 2. Be careful with this fraction. Like, obviously, what you got to realise is you've got two terms on top. Both of these terms are being divided by 2. Don't just do the 6 divided by 2 and think you can leave it like that. Like, you have to divide both of these things by 2. Let's just simplify this first. So what's the square root of -4? Well, the square root of 4 is 2. The square root of -1 is I. So the square root of -4 we could write as 2i. All divided by 2. So now we can divide both of these things by 2. 6 divided by 2 is 3. 2 divided by 2 is 1, so 1i we can just write as I. Okay. I'm going to show you another technique which is a little bit quicker, but obviously the quadratic formula will always work as well. So the next technique we can use is completing the square. Okay, so if we want to solve a quadratic, we can write it in the completed square form. So remember, minus 6, we halve that, so it becomes minus 3 squared. Subtract always outside. Minus 3 squared is 9, but we're subtracting the 9 plus 10 would equal 0. Let's simplify this. So we'd get x minus 3 squared minus 9 plus 10 would become minus 1. Sorry, plus 1. Okay, so just maybe do a little bit of a recap on completing the square if you're a bit rusty on that, but essentially all you do is you halve the coefficient in front of the x, and then outside square this term. So 3 squared is 9, but you subtract that. Essentially, because if you imagine you expand this bracket out, you'd get x squared, you'd get minus 3x, you'd get minus 3x, you get your minus 6, you'd also get an extra plus 9. So whenever you complete the square, you always have to subtract this term squared, because otherwise it wouldn't be the same as what you started off with. Once we've got it at this point, how do we solve this? Okay, so something squared plus 1 equals 0. You don't want to expand the bracket out. If you expand the bracket out, you're back where you started. Leave the bracket, because if you've got something squared, the next step, remember, we're trying to solve this, so we want to get x on its own. Something squared, how do you get rid of that? Square root. Okay, before we square root, subtract 1 from both sides. So I've got x minus 3 squared equals minus 1. Now I can square root both sides. So that would leave me with x minus 3. When I square root, don't forget the plus and the minus. And you square root in minus 1. Okay, so we'd get x minus 3 plus or minus. What's the square root of minus 1? I. The whole point about this topic, isn't it? So x would equal, add 3 to both sides, 3 plus or minus I. Okay, it's up to you which technique you use. You can use the quadratic formula, or you can use completed square. It's good to know both ways, especially because it's been a while since you might have seen this. Okay, we'll try one more example. Okay, the next one, example 2, we've got 4x squared minus 12x plus 13. And your first instinct whenever you see a quadratic maybe is to try and factorise it, but this, don't forget, you're not going to be able to factorise this, because if we're getting complex solutions, we can't put it into 2 brackets with real numbers. It's not going to work. Okay. Should we complete the square on this one? I mean, you can, but it's going to be a bit awkward because you've got 4x squared. Like, I would normally use the completed square form if it's just 1x squared, because it's a bit quicker. But because we've got 4x squared, you might actually think, oh, should we divide everything by 4? Because we're allowed to do that, because we can divide the whole equation by 4. But that would give me a fraction over here. So I think for this one, it's probably best if we just go straight to the quadratic formula. Okay, so x would equal minus b. So minus 12 would become plus 12. Plus or minus square root of b squared, which is minus 12 squared, minus 4 times a, which is 4, times c, which is 13, all divided by 2a, which is 2 times 4. Okay, so we've got 12 plus or minus square root of divided by 8. You can use a calculator for this bit. Okay, we've got minus 12 squared, which would be 144, minus 4 times 4 times 13, so that'd be 16 times by 13. And that gives us 208. So we've got 12 plus or minus 144 minus 208 would be minus 64. All divided by 8. Don't try and divide by 8 yet, okay? you want to simplify this first, okay? So the square root of 64 is 8, but it's minus, so the square root of minus 1 means this becomes a complex solution, all divided by 8. Remember, both of these things are being divided by the 8, so 12 divided by 8, we can simplify down into 3 over 2, plus or minus 8 divided by 8, which again is 1, so I. Okay, so we get 3 over 2 plus I, 3 over 2 minus I. And that's how we can solve quadratics using complex numbers for our solution. Thanks, guys.